So thank you all for coming. I think today we're going to walk through a couple of technical talks. Mine's focused on trusting a 10-minute A&D evaluation. It sounds like it should be simple, but it's something that's a little bit more difficult than you might think. And when you walk through looking at an A&D evaluation, right, we've all used different software packages, and there's different, I'm going to call them release points, where you might make a decision, walk away from the software and start doing analysis in another package. And all of those release points cause you to need to be aware of another software usage, move your data from one application to another, and those are what really cause some inefficiencies in this overall A&D workflow. And I picked 10 minutes because it sounds nice, and the idea behind it is it's something you're trying to do to increase the amount of engineering you can do in a day rather than data mining. Right? We're trying to get away from being accountants and get back to making engineering decisions. So the difficulty in doing that is we've got data coming at us from all different sources. Right? Whether you're going to use IHS or you're going to use Drilling Info or someone gives it to you in spreadsheets, or you're in a data room and they give it to you in another database type, whether it be Aries, PhDWin, or Value Navigator. All of these are coming at you in different ways. So how do we make it easier to work with that data? That's a big challenge. The next one is that forecasting by hand, taking that data, putting a production forecast on it, takes time. And so if you're trying to look at multiple acquisition opportunities, multiple data sets, each one of those requires manual forecasting, and you're going to start bumping into yourself. How do we make sure that we prevent that from happening? Being able to run multiple price sensitivities, multiple forecast sensitivities, multiple op cost sensitivities, that's tedious because it's essentially resetting up a new database every time, run economics, and you're comparing them typically in Excel. Again, we've now deviated from one application. We're in Excel and doing our diagnostics there, and that is a tedious process. And then the last piece is when you do that initial engineering work, and we're talking specifically about an A&D evaluation, if you decide as an engineer, I need to spend more time looking at this data, this is important to my company, we've decided we want to go to the next level, don't throw it away. Don't take that information and say, well, I did my A&D evaluation, I'm going to go to a new software and start over. That doesn't make sense. So what do we need to do to make that 10-minute A&D evaluation a useful 10 minutes? And it's really come down to this. We need to utilize software to speed up our forecasting. Right? We have to build trust. That takes time. So let the software vendors do things to help build your trust. Put it to the test. Bring up the software. Run it multiple times. And if it doesn't look like it's holding up, ask the vendor why. If they can't defend it, that's a problem. The next thing is to define a workflow. Many of us struggle with this in day-to-day life. It's not just engineering. You want to make sure what you do is repeatable. Because if it's not repeatable, how can you compare apples to apples? So I've suggested a couple of steps to walk through doing a 10-minute A&D evaluation that will make sure that you get value out of it. And this centers around a very important piece that I will get into that we have to build trust with. Using technology to make our life better. Auto forecasting is a negative term in the industry. People don't trust auto forecasting. So don't think of it that way. This is assisted forecasting. But use computing to scale through bulk well imports. If you're going to import 100 wells or 500 wells, does it make sense to manually forecast them? Or does it make sense to audit them? I would venture that auditing is better. Run your forecast, let the computer decide what the data looks like, and then you use your engineering judgment to say the computer's right or wrong. The next piece is to be able to run economics consistently. And that means don't jump to another program. Stay where your forecasts belong. If you can do your forecasting in one application, tie on economics. That allows you to do a lot more flexibility in your engineering. I want to look at different op costs. I want to look at different price decks. I want to run all those simultaneously and then compare them. The next piece is sorting and bucketing and doing analog forecasting. So I want to look at a data set, find out which wells belong together, and then use those to build a type well. Use that information to analog forecast wells that have a month of history, 2 months of history. Because when you're using a computer, even 1 or 2 months of data, it's not enough to trust that the algorithm is going to give you a forecast. So use analogs, use your engineering judgment, and more importantly, don't let somebody tell you that it takes too long to build a type well. Why don't you build 4 or 5 of them at a time with different assumptions, overlay them on top of your production, and then make an engineering decision which one makes the most sense. And the last piece is being able to review your economics inline. Make sure that you can run multiple scenarios. Make sure that you can compare those scenarios. This gives you more and more information to be able to make your decision. And the last piece here on this is what I said originally, which is keep that data in an application that allows you to continue your work. Don't throw it away and start over. Right? You're devaluing your engineering if you're saying, I need to go and start again because I need to get to the next level. So in coming up with this idea of how to do a 10-minute evaluation, I was actually challenged by a colleague, and he wanted to see if auto forecasting really did make things easier. So we went and found a 100-well data set, and we both said in 10 minutes we're going to come back and compare. He was using another application. I won't get into which one it was, but I was using Value Navigator and running auto forecasting. 2 very important things happened. 1, we both finished our A&D evaluation in 10 minutes. We forecasted all 100 wells. We had results. My buddy came to me and said, well, no, I was able to keep up from a forecasting standpoint, but I don't trust my forecasts, because he was so frantic trying to do 100 wells by hand that he had no time to do anything else. I was able to forecast the 100 wells, audit them, go through the forecasts 2 or 3 times, and that took about 5 minutes. I spent the next 5 minutes building economic cases, running price decks, building a type well, doing analog forecasting, and was even able to run a very brief rig schedule. All in 10 minutes. And the reason for that is I have put the software to the test, and I trust that I can make engineering decisions based on the suggestions made by the application. So what does this look like? I've got some screenshots. I wasn't going to go into a demo of the application, but running multiple forecasts at once is important. I can set up parameters to say I need to know a low, mid, and high side. Show me what that looks like so that I can make a decision on which forecast I want to run with. I told you we need to be able to do comparisons of economic runs, scenarios, or forecasts. What does that look like in your software? Does your application allow you to make decisions inline, run all the economics, and then do a comparison of them right there in the application? Are you able to do break-even analysis? So if I want to know that my price decks make sense, am I too high? Am I making too negative of an assumption so that I can't continue moving forward? All of this is intended to increase your screening proficiency. Because when you're doing a 10-minute A&D, this isn't the known answer. This isn't going to be what you engineer your field off of. It's to make a decision on whether you want to continue analyzing this data set or put it aside because there's more important things to look at. Are you able to build type wells in the application and then run with it? When you build type wells in Excel, you've got to do manipulation outside of the application you're working in. You've got to assign some equation parameters and then bring them back into your economics package. So let the vendors know, let software companies know that this is a workflow you're trying to achieve. That's the whole reason we included it. Is let's make sure you don't need to leave the application because that introduces inefficiency. And lastly, are you able to generate a drilling schedule? This isn't something that you're going to send to operations, but if I need to know, if I buy this acquisition and I intend to drill X number of wells, I need to know a back-of-the-envelope answer. I need to be able to assign some value rather than grabbing a type well and say, I'm going to multiply this 10 times. So a 10-minute A&D is not intended to be the answer or how you do your engineering. It's a way to practice screening, and it's a way to practice quick looks and trusting software to help you be more efficient as an engineer. So you got to ask yourself, do you have these opportunities in your application? And if not, is there a way for you to look for it elsewhere? We've spent our time looking at these problems, making sure that this is a possible solution, possible workflow, and it's been tested. I've lost count of how many times we've tested it. But what we're trying to do is, as a software company, not make big claims, but stand by it and prove that it's what we can do. So I tried to make this talk about 10 minutes. I thought that would be fitting. If you guys have any questions for how to run a 10-minute A&D, or what we've seen while we're doing it, or if you want to go into more detail about that challenge we did, by all means, ask away.